Separable differential equations. Let's look back at a previous example. If dy dx is equal to 6x, then y is equal to 3x squared plus c. By integrating each side, or finding the antiderivative of 6x, we are able to arrive upon the general solution of the differential equation. But what if we're given a differential equation such as dy dx is equal to 4x cubed y squared? We now have a function in terms of both x and y. The antiderivative is not so clear this time, and thus we need an alternate approach to finding the original function. I'm going to define the phrase separable differential equations. A separable differential equation is a differential equation that is in terms of both x and y. In other words, if dy dx is equal to f of x times g of y, or if dy dx is equal to f of x over g of y, we call these separable because any terms involving x are able to be separated on the other side of the equation, away from any terms involving y, to yield the following. So if I take my first one and I multiply both sides by dx and divide by gy, I get this equation right here. If I cross multiply dx and g of y here, I obtain this differential equation, or this solution, gy dy is equal to f of x dx. Example number 1. Solve the following differential equation using y of 1 equal to negative 1/2 as initial condition, and the differential equation we're going to consider is dy dx is equal to 4x cubed y squared. So our question, as with any problem, is how do we start? Well, first let's algebraically move all the x terms to one side and y terms to the other side, and we're going to include dy dx as part of that process. So I obtained the new differential equation, 1 over y squared dy is equal to 4x cubed dx. How did I get that? Well, some basic algebra looks like this. If I multiply both sides by dx, on this side it's going to cancel, and you can see I have my dx over here on the left side. If I divide both sides by y squared, okay, again on this side it's going to cancel, but on this side I'm going to have 1 over y squared dy. So I have separated my variables in terms of x and y. Now we can easily integrate both sides respectively. When I integrate each side, adding the constant side to one side of my equation, I obtain negative 1 over y is equal to x to the 4th plus c. But why only one side? Let's analyze that a little bit further, and I'll start my discussion right here. If we add two different constants, let's call it c1 and c2, to each side, we can bring the constants together by subtracting c1 from both sides of the equation. Since subtracting one arbitrary constant from another yields another arbitrary constant, we are able to add only one. Or we can call it just c because they're both arbitrary constants. So if I start off, let's say I have negative 1 over y plus c1 for my arbitrary constant on the left side is equal to x to the 4th plus c2 for my arbitrary constant on the right side. I subtract c1 from both sides, and I have negative 1 over y is equal to x to the 4th plus a brand new constant, we'll call that c3. And I could easily just rename that plain old c for my arbitrary constant. Now we have the general solution, but since we've been given an initial condition, we have to continue. So I'm going to take my point 1. Oh, that should be a negative 1/2. Let me fix that real fast. Okay, so yeah, see it's negative 1/2 up here. So this should be a negative 1/2 right there. Okay. So I'm going to substitute 1 negative 1/2 and solve for c. So my negative 1/2 is going to go in for y right here. And my positive 1 is going to go right here for x. Okay. And I have this brand new equation. negative 1 over negative 1/2 is equal to 1 to the 4th power plus c, and that tells me that c is equal to 1. Now I substitute c equals negative 1 into the general solution and solve for y, and that gives me negative 1 over y is equal to x to the 4th plus 1. But solving for y, we get our final general equation, or a specific equation. Y is equal to negative 1 over x to the 4th plus 1. Steps to solve separable differential equations. Let's organize the steps we just took so we have a guide to follow when solving these types of differential equations. Number 1. Algebraically move all x terms to one side and y terms to the other side. Include dx and dy. Number 2. Integrate each side, adding the constant c to only one side of the equation. Number 3. If given an initial condition, substitute and solve for c. And number 4, solve for y.